So in this video, we're going to list all of the product to sum and sum to product formulas. There's a lot of them, so let's get started. So basically, these can be derived from the sum and difference formulas, and it's not super complicated, but there's an element of it where you have to do a change of variable that is not so straightforward. So we'll skip demonstrating these identities unless someone asks for it, either post in the comments or email me, and I don't mind making a video doing that. It's just we can skip that detail for now and add it in later if needed. So the first one is cosine alpha cosine beta. If you have a product of two cosines with different inputs, right, alpha and beta are different, at least potentially, otherwise you wouldn't bother doing this, then here is the corresponding formula. This is 1/2 of, I'm going to use brackets because I'll have parentheses, I want to distinguish the two, of cosine of alpha minus beta plus cosine of alpha plus beta. And as you can see, look, I was saying, hey, there's going to be sum and difference, or difference and sum angle formulas involved here. So you can construct this whole identity from identities that we already have. It does take a little bit of effort. It's not extremely straightforward, especially when we get to the sum to product formulas. Those are a little bit more work to show. These are not too bad, but we'll skip the details for now unless someone asks for it. So the next one is sine alpha sine beta. So this is 1/2 times cosine alpha minus beta minus cosine alpha plus beta. So they're very similar, and that's, well, because they come from the same identity, so they're going to have similar components. The problem with this, though, is if they kind of look similar, then it's hard to memorize these. So to some degree, you're going to have to rely on having a formula sheet for these in particular. The next is sine alpha cosine beta. Okay, and this one is going to use the sine rather than cosine in the other half of this equation. So this would be 1/2 of sine alpha plus beta plus sine alpha minus beta. Okay. And then there's one more product to sum formula. It's sort of redundant. You don't need it, but it doesn't hurt to have both. So the next one is cosine alpha sine beta. And this is going to be 1/2, and very similar to the one that precedes it, 1/2 of sine alpha plus beta minus sine alpha minus beta. Okay, so those are the four product to sum formulas. This last one, in some ways, is redundant when you have the one that precedes it, but that's fine. It doesn't hurt to have the full list anyway. So now let's get to the sum to product formulas. And again, these are relatively easy to prove. These other ones, not so much. They're a bit more involved. So sine alpha plus sine beta. So if I have a sum of two different sine functions with different inputs, how do I combine those and create a product? Well, that would be 2 sine, and this is where it gets a little dicey, alpha plus beta over 2. So the average of the two angle values times cosine of alpha minus beta over 2. So the average of basically half the difference of the two. So yeah, I'm pretty sure you'll agree this definitely looks more complicated because you have these fractions involved. The next one is sine alpha minus sine beta. And this is fairly similar. It's just basically the order is switched. So yeah, I'm going to go ahead and there's options on how to write it. I'll just write it the way that the formula sheet I put on Blackboard is. So it's the same thing. So this is cosine of alpha plus beta over 2 times sine of alpha minus beta over 2. Okay. And then cosine alpha plus cosine beta that's going to be 2 cosine alpha plus beta over 2 times cosine alpha minus beta over 2. And then the last one is cosine alpha minus cosine beta. Okay, so this is going to be a negative 2 sine of alpha plus beta over 2 times sine of alpha minus beta over 2. Now, the order that these are written, the order of the factors, because when you have two things multiplied, you have two factors, the order doesn't matter. 2 times 3 is the same as 3 times 2. Notice that the alpha plus beta over 2 goes first every time, and the alpha minus beta over 2 goes second every time. That's not essential, and in fact, if we were proving these, for some of them, it would make sense to do the other order. In particular, these two, changing the order of the factors would make sense if we were proving them, because you would see more clearly where things come from. But we're not, we're just listing them, so that's the list.